Hello, this video is going to be reviewing some probability and statistics information that will likely show up on the MCA test. So just trying to get ready for that test. These videos will cover that. The first topic we're going to go over is the number of ways you can do something, or number of ways things can occur. And there's really three different types of problems. The first is a counting principle, and to help try to tell these apart, the hint for counting principle is if you have multiple categories. So the classic example is picking an outfit where you have like 5 shirts and 4 pairs of pants, and you're making one outfit. So you select one of the shirts and one of the pairs of pants to wear to school that day. And so the counting principle is you take just your shirt option times your pant options, and it gives you 25 outfits. And again, the hint for telling that it's counting principle is it's multiple categories and you pick one from each. Okay, in the permutation combinations, it's just one category, and usually you select more than one. So like selecting 3 out of 5 students or something to win a prize, that would be either permutations or combinations. And the difference between these two is order matters in permutation and order does not matter in combinations. So if I'm selecting 3 out of 5 students, it could be permutations or combinations. If the prizes are different, then it would be permutations because you want to win the best prize, so the order that you're picked in matters there. Versus if everybody gets like one small pizza or something, then the prize doesn't matter, and then the order doesn't matter, and then it becomes combinations. Okay, and for permutations, anytime they talk about like ordering something or arranging it, then that's a sign it's probably going to be permutations versus combinations. So I'm going to throw a few examples at you. Again, I encourage you to pause them and try them before moving on. And again, you got to figure out, is it permutations, combinations, or counting principle? Okay, so basically this is counting principle because it's how many different calendars. So basically we've got 4 types of calendars based on the length. And then for each type, they come in 4 different colors. So it's basically 4 types times 4 colors for each type means there's 16 possible calendars. Okay, pause the video and give this one a shot. Okay, 4 students want to play on a soccer team. The coach can choose 1, 2, 3, or 4 of the play. How many different combinations? Okay, so they tell us this one's a combinations. And then this is wild because you've actually got to do like 4 kids and you pick one because the coach can choose 1, 2, 3, or 4 players, which is kind of weird. So you've got to do 4C1. That's if he picked 1 player. And then if he was to choose 2, it'd be 4, he or she, I guess, would be 4C2. And then if they were to pick 3 players, it would be 4C3. Because again, the order doesn't matter. And then if you picked all 4, it would be 4C4. So you've got to add together all the different possible combinations, assuming they picked 1, 2, 3, or 4 players. So really it's just a thing on your calculator. So if you've forgotten where those buttons are, you got to type the starting number first, the bigger number. So in all of these, I type the 4 first, and then I go to math and go over to probability, and here's your permutations, combinations buttons. So I'm going to do number 3 for combinations. 4C1 is just 4. You're only picking 1 player, so there's really 4 ways to do it. Okay, and then just keep doing the rest of them. 4, math, probability. So there's 6 ways to do that one. And then I think these other 2 are going to be both 6 and 4, but we can verify real quick. So I'm glad I did it because I was wrong. 4C3 is 4, and 4C4 is 1. So let's go back and finish this. So this one was, this one was a 4, and this one was a 1. Okay, and if we add all of those up, I think this should be 15. That's kind of a wild question because you got to do combinations a few different times, but the right answer is just 4 plus 6 plus 4 plus 1. Okay, again, pause the video and give this a shot before watching the solutions. All right, so this one hint, they tell us it's combinations, and it's one category, just CDs. You have 8 of them, and you're taking 4, and clearly the order doesn't matter, right? These, if they're in the bag or they're not, right? So your Justin Bieber CD is either in there or not. It doesn't matter if you pick Justin Bieber first or last; it's still in there. So then it's just a matter of doing on the calculator 8C4. So 8, the bigger number first again. Math, probability, number 3, combinations. Looks like there's 70 different groupings of 4 CDs you could take with you. Okay, pause the video. This one's a tricky one again, so pause the video and give this a try. Okay, so the first thing is I don't really like the word combinations here because this really isn't a combinations one. You're just picking 2 health. So because you're picking like one, you're picking one doctor and one dentist, or like one dentist and one nurse. This is really a counting principle because you have 3 categories of doctor, dentist, nurse. Okay, and what's confusing is you're picking not one from each of these, you're picking just 2 healthcare providers. So if you did a doctor and a dentist, it would be 12 possibilities because you have 4 doctors times 3 dentists. If you did a doctor and a nurse, you do 4 times 5. And then if you did a dentist and a nurse, it would be 3 times 5. Okay, and so how many different 2 combinations are there, I guess? Combinations of 2 of them, you have to add up all of these. There's 12 doctor dentist, so this one's doc, dent. There's 12 doctor dentist combinations. There's 20 doctor nurse combinations, and then there's 15 dentist and nurse combinations. So all total, add all those up, and I think you get, is that 47, I think? So there's 47 different possible 2 healthcare provider combos. Okay, we're going to shift gears, and now we're going to do probability. So when you do a probability, you just got to figure out the favorable outcomes out of the total. So like a good example of this is like free throws in basketball. So let's say you take 10 total free throws. Your probability of making it is how many you've made out of the total. So let's say you make 6 of them, and your probability to make a given free throw is 60%, which you can write as a decimal like that, or you can shift the decimal point over twice and write it as 60%. Right, so when you do a probability, just do favorable out of total. Okay, and then a couple others. So like on a lot of probability ones, my advice is just do what makes sense, to be honest. Right, but that being said, like if the problem mentions and, oftentimes what you have to do is multiply the individual probabilities together. Okay, so let's say the one I always use is what's the probability the Wild win the Stanley Cup and the Timberwolves win the NBA Finals? Right, so to do that, you'd have to do the probability of the Wild win, which is, again, is not very good, and multiply it by the probability the Timberwolves win, which is also probably not very good. So let's say the Wild have only a 1% chance, and the Timberwolves, they're a little bit better, so they have a 3% chance. But the chances of both of them winning are multiply those together, and you get, I forget how many zeros this is, but it's not very good. Right? It's a very small amount of chance of it happening. All right, so something like that is our answer there. Okay, and then if the question mentions or, again, I would normally do it to make sense, so I have this wrong here. This should be a plus. If it's an or one, you add the individual chances together and then minus any overlap, anything that got kind of counted twice. So like, I don't know, the simple example I can do here is probability you get from a deck of cards, you get a heart or a face card is kind of the classic example. So to do this, you take the probability to get a heart plus all the face cards, so probability of face card, but then some get counted twice. The ones that are both heart and face cards get counted twice. So the hearts, there's like 13 out of 52, and the face cards, there's 12 out of 52. But if you look at a deck of cards, there's 3 that are both face cards and hearts, so they got counted twice, so you got to minus those off. Right, so this one is like 22 out of 52 is a chance you get a heart or a face card. Anyways, here's your first probability one. And basically this one is just figure out what is the favorable out of the total. Pause the video and give it a shot. Okay, so it's got 6 possibilities, 1 through 6, and we want to get anything that is not a 3 or a 5. So sometimes I draw these out, right? So basically everything counts except the 3 and the 5. So if we look at everything else, there's 4 of them that are not 3 or 5. So your chances of getting a not 3 or 5 is 4 out of 6, or 2/3 chance, like about 67%. Is that probability there? Okay, read over this one and then watch the solution. Please note that we're not putting the book back. You're taking one and then taking another one. Okay, so this is what is the probability that he picks a biography and a technical book, and then picks a technical. So basically we're going to multiply because this is an and. So our probability that you get a biography, it's a little bit easy to figure out. It's easier to figure out, I guess, is 5 out of the 40 books are biographies. So we're going to multiply that by the chances that the second is a technical. So when you pick the second book, there's only 39 left. And the technical books, since we picked a biography first, all the technical books are still there. So on the second book, there's 11 out of 39 that are technical. Okay, and then the only thing I'd recommend here when you're doing this is before I multiply, actually reduce. So like 5 over 40 reduces to 1/8. So I would definitely reduce it first. And then my numerator is just going to be 11, and my denominator is going to be 8 times 39. All right, so we get 11 over 312, which has a decimal. If you divide it out on your calculator, it looks something like this. And if you move it over twice, there's about a 3.5% chance, which is not very good, but generally that's how AND works. If you have to do this, and this, and this, the more things you have to do, the less likely it becomes. So getting a biography and then a technical book is not very good, just 3.5% chance. Okay, so this one is, normally when you flip a coin, it's just a 50-50 chance of heads or tails, but this time it's unfair, meaning it's not 50-50. And let's see, it's 5 times more likely to land tails than heads up. So what is the probability that the unfair coin lands heads both times? So basically this is another and one, because you have to get a heads and another heads. Okay, and it's not going to be very good because it's 5 times more likely to be tails than heads. So that, so I don't basically see if you can figure out your chances of getting heads on one flip and then kind of go from there. Okay, so if it's 5 times more likely to be tails, so basically every time you get a heads, there's going to be 5 tails for that. Right? It's 5 times more likely. For every 1 heads you flip, there's going to be 5 tails. So if you look at these 6 total trials, only 1 out of 6 is a heads. Right? That means tail. That's how it would be if tails is 5 times more likely. So your chances of getting heads once are 1 out of 6. And if you have to get a heads and a heads, you just do 1/6 times 1/6. So you only have a 1 in 36 chance of getting heads both times. Okay, ran out of time, so I'll make a part 2 for this lesson. Thanks for watching.